Hello once again, it's David Stokes from Convalido Consulting, and in this video we're going to look at how the Convalido data lifecycle modeling tool can actually be used to put some data lifecycle diagrams together. Hopefully by now you'll have seen the videos looking at the various lifecycle operations we can use and also the data attributes associated with those. What we're going to do now is actually start to put together a real lifecycle. As an example, I'm going to choose a particle size analyzer as an example, typically used in granulation in a laboratory, for instance. And the key thing about a particle size analyzer is it gathers multiple items of data. It associates those data typically with different channels, with different ranges, and it gives a particle size distribution. So it's not just a single item of data, there are actually multiple items of data and associated metadata. So the first thing we need to do is look at some automatic data acquisition. So if we go to our data acquisition stencil here, and what we're going to choose is some multi-point data here. So at this stage we're just going to look at a very simple signal. Typically we're looking at some sort of signal from a detector which gives a distribution of particle size. At this point it is purely converting an electrical signal into some sort of data with no associated metadata. So that's going on there. As we've seen in one of the previous things, we can add shape data here. So I'm going to put here particle size distribution, and this is raw data. We'll come back to raw data in a moment. Raw data is very important. I'm not going to fill in the rest of the fields at the moment. Typically what happens once we've acquired that data, it needs to be stored, and that needs to be stored on a temporary basis. It's not the final data, but this is purely a record of the signal as represented by the raw data. So we need some data storage, and the question we need to ask ourselves here is this going to be temporary data storage, or is it going to be permanent data storage? And we need to think about what the regulators require here. Very often in an analytical instrument there's a requirement to retain raw data long term for subsequent reprocessing. So what I'm actually going to do here is choose permanent data storage for multiple values. Again, at this point there is very limited metadata, no metadata. Now I can leave a space between those if I want, that's fine. I can sometimes put them together, and you'll see the shapes are sized to fit together nicely and linked together and line up well. So you can just put them in a row. You can obviously put lines between them. I'm just going to put these next to each other for now. Now obviously somebody needs to put some information about this data acquisition in place, so we're going to need some data entry, and we're going to get an operator to again enter multiple items of data. Typically this might be the sample identity for the sample that's being analysed. It might be the batch number, for instance, and this data will be entered into the instrument manually. Now this isn't raw data, so we don't need to store it permanently. So in this case we're okay to store multiple values. Again, this is data, and we're going to store this on a temporary basis. So there's our little temporary data storage value here. What then happens in the instrument is we do some data processing. We take the data represented by the signal, the raw data. We take the metadata. That may include things like the definition of our channels against the various particle size ranges we're interested in, and we're going to do some processing. So in this case we're going to look at some multiple items of data with metadata, because actually what's happening here is the data that's been entered manually is the metadata associated with the raw data that was acquired automatically. Now I'm obviously going to need to put a little line in here, so let's look at our connectors. Pick the appropriate connector. Here's one, that will do. And again, you can see the connection points highlighted here. The connection points have been specifically put in place here so that the items of multiple data and the items of single data, the connection points actually line up neatly. So what happens after we've done our processing? Well, again, we want to store this data on a temporary basis within the instrument itself. And again, we need to think about where we're going to go to rely upon this data for regulatory purposes. Do we go to the instrument or do we go to an external system? In this case, let's assume that the data will be transferred to an external system. So the data we have here is just going to be temporarily stored in the instrument until it's overwritten. So again, we need to pick multiple data. At this stage, it has metadata, so it's stored temporarily. At this stage, once the analytical run is complete, we typically want to move the data into another system. This might be a LIMS system, for instance. It might be an ERP system. So we now want to do our data move or a data copy. We have to think about whether it's a move or whether it's a copy. If it's a copy, the data will be retained in the instrument. Well, obviously, we need to retain our raw data for possible subsequent processing, but this processed data is going to be stored elsewhere. So what we're going to do here is define this as a data move. And that tells us that the data needs to be stored long term in an external system. So we need to have the data stored in an external system. Let's pop that over there. I can just copy and paste this connector. Again, everything lines up neatly because of the connection points we put. But this will typically be part of the batch data. So it's part of an electronic record. Selected that. I'm now going to just move that to the back. So here's our basic data lifecycle for this single point of information. Now we can use other Visio shapes and stencils. So if I go to basic shapes here, for instance, open that up, I can just drop a rectangle onto the page, move that to the back so that it underlies all of my, let's do that again, send it to the back, and I can now slip it under here to define the boundaries of my particle size analyzer system. Okay, there we go. Again, I can use whatever I want from Visio, so I can go to more shapes and pick something. Let's pick a picture of a computer, for instance. Anyone you like. There we go, just put that there. That represents my analytical instrument. Again, whatever you like. It's standard Visio, so we've not done anything to take anything away there. Apologies to any Americans watching and analyzer. I'm using good old British English. So format that as you wish. Now again, each of these shapes has data associated with it, as we looked at previously, and it's very easy to copy and paste that. So if I go to data here, for instance, I can just select this. This is the raw data, copy it there. Okay, here I can just say particle size distribution with metadata. And again, it's very easy just to copy and paste between the data shapes from one area to the next. So particle size data, so this is where the metadata comes from. And that's how we create the diagrams. In our next video, we'll take a more detailed look at how we actually use that data to produce our risk assessments.